This video is going to be on factors that affect the urine concentration, which of course we measure by the USG. And I'm going to go through 6 main factors, the first of which is the number of functioning tubules. And the magic number of functioning tubules is 66%, or 2/3. So if you lose greater than 66% of your functional tubular mass, then you see a decrease in your urine-specific gravity. There's a failure to concentrate the urine. And of course that's going to depend on what species you're looking at, so that'll be 1030 in the dog, 1035 in the cat, and 1025 in large animals. So you see this loss of functioning tubules with renal failure. The second factor that dictates the urine concentration is the tubular flow rate. So if you have an increased flow rate, then there is less time to reabsorb water, so there's a lower urine-specific gravity. And if there's a decreased flow rate, then there's more time to resorb electrolytes in water, so that could lead to an increased urine-specific gravity. So things that cause an increased flow rate are diuresis, and this could be due to either increased water intake, so maybe your animal just likes to drink a lot of water, or perhaps IV fluid administration, or something we call osmotic diuresis, where there's osmotically active particles within the tubule that keeps the water in the tubule. Now, going to a decreased flow rate, you can get a decreased flow rate with decreased renal perfusion. And that can happen in 2 situations, either dehydration or if you would administer drugs to the animal, and then that will cause decreased renal blood flow. So either of those instances are the most common for decreased renal perfusion. The third factor that influences the USG is the medullary tonicity. Now remember that this interstitium, which is the area between the tubules, is made up of lots of sodium and chloride and lots of urea, and that sets up a gradient where water can be resorbed. So if you have a total body depletion of either sodium or urea, then that gradient is no longer there. So you can get loss, like a total body depletion of sodium, with any cause of prolonged diuresis, so diabetes mellitus causing osmotic diuresis, or chronic increased water intake like psychogenic polydipsia, or you can get it when there's liver failure, so with liver failure the liver's not producing urea. And along those lines, portosystemic shunts could also cause low urea production, because with portosystemic shunts, the total liver mass is reduced. So again, you're not producing enough urea. And then another reason why you would have a total body depletion of sodium besides diuresis, which I already mentioned, is a deficiency of aldosterone, and I'll just abbreviate that ALD. And that's because aldosterone is a molecule that helps resorb sodium from the ultrafiltrate. Okay, so a fourth factor that affects the urine-specific gravity is aldosterone. Aldosterone is a hormone that is released by the adrenal gland, and its actions are to resorb sodium, chloride, and water from within the tubule lumen, and then also secrete potassium and hydrogen ions. So if there is a deficiency of aldosterone, such as hypoadrenocorticism or Addison's disease, then you would have less resorption of water. Okay, so the 5th factor that can influence the USG is ADH. So ADH, or antidiuretic hormone, is a protein that's released by the pituitary gland, and it acts to resorb water and to some degree urea as well. So if there's less ADH, then there's less water resorption. And this happens very rarely with a disease called primary diabetes insipidus. Primary diabetes insipidus, or primary DI, is when there's some sort of pituitary disease or dysfunction that's resulting in less ADH being released. And then the last reason that can alter the urine-specific gravity is decreased responsiveness to ADH, or an altered responsiveness to ADH. So on the collecting ducts, there's receptors for ADH, and when these receptors are altered, or the messaging pathway that the receptors lead to are altered, then this can lead to decreased responsiveness to ADH. So there's actually lots of different things that can alter the responsiveness of ADH. There's over 20, 30, even probably 40 documented in human medicine, but we most commonly see a very few number of those routinely in veterinary medicine. And when this happens, we call this secondary diabetes insipidus. So causes of secondary diabetes insipidus include hypercalcemia, hypokalemia, Cushing's disease, also known as hyperadrenocorticism, as well as E. coli infections such as pyometra, pyelonephritis, UTIs. And then it's thought that hyperthyroidism and hypoparathyroidism also lead to secondary diabetes insipidus, but the mechanism there isn't completely understood. So that pretty much sums up the main factors which affect urine concentration: functioning tubules, flow rate, aldosterone, ADH, responsiveness to ADH, and also medullary tonicity.